Hey guys, welcome back. What we're going to take a look at today is applying the multiplication and division laws to exponents. So what I'm going to start out with here is a quick review. We did exponents back in 6th grade. So this is just a brief review to refresh your memory of what are exponents and what they mean. So an exponent simply tells you how many times a number, or the base, is used as a factor. So you'll notice I color-coded this. Here my base is 10, so this is my factor. My exponent is 5. So what you'll notice, I wrote it out here. So what I'm saying is I want to multiply 10, my base, 5 times. 10 times 10 times 10 times 10 times 10. And then you'll notice there's a couple different forms we can write them in. Again, we talked about this last year. This is what we would call exponential form, just leaving it as an exponent with the base and the exponent. This would be our factor form where I'm writing out what I'm doing. I want to multiply 10 5 times. So I've written out my multiplication. Over here we have what we call standard form, meaning I've done the calculation now. I've done this factored form. I've multiplied 10 times 10 times 10 times 10 times 10 to get 100,000. So, again, this is still just the brief review. So we're just going to write these in their exponential form, meaning write it with the base and the exponent. So if you look here, I have 3. So that means my base is going to be 3. What's my exponent going to be? Well, all I have to do is count. How many times am I multiplying it? Here I have 5 3s that I'm multiplying. So in exponential form, it would be 3 to the 5th. Here, you'll notice I'm multiplying 2s. So that means my base or my factor is 2. And then we're just going to count up how many times are we multiplying it. 1, 2, 3, 4, 5, 6, 7, 8. 8 times. So this is just 2 to the 8th power. Multiply 2 8 times. And remember, when you're calculating, you're not multiplying these two numbers. This is telling you how many times to multiply that base number. All right, here you'll notice I have -4s. Now down here I gave you a little side note. Why? Because we don't want to get confused with the negatives down here. The way we write it is important. Here I have -5 squared. Here I have the -5 in parentheses, and I'm saying square it. These mean two different things, so don't get confused with this. The way I would write this -5 squared means square your 5, which is 25, then add in your negative sign. Whereas over here, what I'm saying is I want to multiply -5 times -5. Don't let these two confuse you, because these are different. These are not the same. One is -25, one is a +25. They're very different things. So keeping that in mind, notice I'm multiplying -4 3 times. So that means I want to take -4, that is my base. I'm going to put it in the parentheses, because if I don't, I'm not going to wind up with the same thing. I'm going to wind up with something different. So I've got a -4, 1, 2, 3. I'm multiplying it 3 times. -4 to the 3rd power, or -4 cubed. So now let's take a look at how that affects how we multiply or divide when we're using exponents. So if we're multiplying exponents with the same base number, we keep that base and we just add the exponents to find out what our answer is, and we would leave it in exponential form. However, if we're dividing exponents with the same base rather than adding, we're going to keep the base, but we're going to subtract the two exponents to get my answers. On the next two boards, I'm going to show you why it is that that works. So here I've shown you an example of multiplying exponents. The quick rule is just add your exponents. Well, why does that work? Well, let's break it down and look at it. If I have 6 to the 3rd, what does that mean? It means I'm multiplying 6 times 6 times 6. If I have 6 to the 7th, what does that mean? It means I'm multiplying 6 7 times. So you'll see I've written it out 7 times here. So if I multiply all of these 6's together, how many 6's am I multiplying? Well, if we look, now that I've written them all out and we count them up, and I have them over here, I have 10 6's, or 6 to the 10th power. Now, this is a very long and lengthy way to do it, which is why I'm giving you the shortcut rule, which makes it a lot easier. Nobody wants to write all of this out every time they do it. So look at your exponents, 3 and 7. If I add 3 and 7, I get 10. Well, that was my answer. So our quick rule is simply add our exponents, 6 to the 3 plus 7, or 6 to the 10th power. That's why it works. On the next one, I'll show you why it is that division works. So here we're dividing exponents. I have 10 to the 9th divided by 10 to the 5th. So again, what I did is I gave it to you in the factor form. I wrote them all out. I have 9 10s here, and I have 5 on the bottom. Well, if you'll recall, anything divided by itself gives me 1. So basically what happens is it's going to cancel out. So you'll notice wherever I had them on top of each other, I just crossed them out. Because that divided by itself is going to give me 1, it's going to cancel out and go away. So then how many 10s am I left with? I'm only left with 4 10s, 10 to the 4th. So again, just take a look at our exponents. How did that work? Well, if I have 9 minus 5, I get 4, 10 to the 4th. Same thing I got here the long way. So the addition and the subtraction of them is just the quicker rule, the quicker way to get to your answer. So let's do a couple examples. So if you look here at number 1, the other important thing to remember here, and the reason I use this one, is because a lot of times people are going to forget this too. A lot of you probably looked at that and said, oh, it's 2 to the 6th. It's 4 plus 2. However, there's a number right here, and it's a 1, because I have 1, 2 there. So whenever there's, almost always in math, if you don't see it, there can be an implied 1. So there's an implied 1 there, meaning I have 1, 2. So don't let that confuse you. If I was going to write this out, I'd have 2 times 2 of them here times another 4. When I add that all together, you'll see that there's actually 7 2s and not 6. We can't forget about this one right here. All right. Over here, our base is 5, so our base stays the same. We add our exponents. 2 and 3 gives me 5, 5 to the 5th. And I'm just going to leave them in exponential form here. I'm not going to do the math to calculate the math. That's fine. Here, again, remember, you see that if it's written as a fraction, that's another way to write division. So we're simply dividing. So my base is 13. My base is going to stay the same. I have an 8 and a 2. I'm dividing, so that means I need to subtract my exponents. 8 minus 2 gives me 6. I'm left with 13 to the 6th. Here, my base is 24, so my base stays the same. Then look at my exponents, a 7 minus a 3. I'm dividing, so I'm subtracting. 7 minus 3 is 4, so I wind up with 24 to the 4th. This one I want to look at because it's kind of a fun one. 7 to the 10th divided by 7 to the 10th. Well, what is our rule? Our rule is that we subtract our exponents. Well, what is 10 minus 10? 0. 7 to the 0. However, what would this equal as a number? And a lot of people try to say 7 or they try to say 0. They get a lot of zeros. It's not 0. What does any number divided by itself give me? 1. Any number to the 0 power is equal to 1. So keep that in mind. And the reason it works is because they all cancel out. 7 to the 10th divided by 7 to the 10th gives me 7 to the 0, which means 1. So here I've got 38 to the 0 power, which is the same as saying 1. What is anything times 1? Itself. So my answer is 38 to the 5th. The other thing you could just do is 5 plus 0. That's our identity property of addition. So it would still be 38 to the 5th. All right.